My name is Chris DePuy. I am a research analyst with Dell'Oro Group. I cover wireless LAN, among other things. And what the plan here is to talk about the new wireless LAN standard called 802.11ac. Now, my hope is that I can go through some introductions of the panelists and spend a lot of time focusing on what they'd like to say. And what I was thinking we could do is I would introduce each of them, but we're not on that slide right now. So I will now speak about some of the research findings we have. Okay. I'm trying to advance the slide. Okay, here we go. Right. So we have five panelists, and so this is a bit more than some of the other groups. I'd like to first introduce Matthew Gast. He's a director of product management at Aerohive, and he leads development of core software for Aerohive's distributed systems. He's the chairman of the Wi-Fi Alliance Security Task Group and is right in the later stages of authoring his third book called the 802.11ac Survival Guide. Next we have Walt Shaw, who is with Cisco, is a director of product management. And Walt's a leader of the team at Cisco that launched the Cisco Clean Air technology. And this technology relates to improving the performance in systems with RF interference. Next we have Stephen Glapa, who is with Ruckus Wireless as a senior director of marketing. Stephen's been there for 4 years and drives many of the marketing initiatives for Ruckus. Ruckus has gone from a startup in 2009, went through the IPO process last year, and is now one of the leading enterprise vendors and has a specialty in the service provider Wi-Fi arena. Angus Robertson is director of global services at Spirent Communications, and he's responsible for product marketing and management of Spirent's integration, automation, and content platform for wireless application and security test equipment. And last but not least is Dirk Gates, who many of you have heard from at this conference already. He's the executive chairman of Xirrus, one of the leading wireless LAN equipment vendors. But before founding Xirrus in 2004, Dirk was also a founder of Xirrcom, an Ethernet company. He was actually founded in 1988, went through the IPO process, and then was acquired in 2001. So these are the panelists that we'll be discussing 802.11ac with today. Okay, wireless LAN is a growth industry. Here we have a growth industry in the networking world. And what's happening here is this market is growing, and we expect it to grow for at least the next 5 or 10 years. And these are the various segments of the market. What we'll be talking about today primarily is the enterprise and outdoor portions of the market, multi-billion-dollar growth industry. What's happening with the wireless LAN market is we're going through a new upgrade cycle that is just starting. That's the topic of today, 802.11ac. Before that, we had other systems like 802.11b, G, AG, and the current large part of the market is 802.11n. We will start to see enterprise class devices with 802.11ac shipping this calendar year. And my last slide here discusses the cooperation or competition between Ethernet switching in the campus and wireless LAN in the campus. You can see last year, enterprise wireless LAN was a relatively small fraction of the total access part of the enterprise market. And in 5 years, we expect the wireless LAN will be a much larger part of that market. And that's the last slide for me with market research. Now, let's go on to the panelists. What I'd like to address here is 802.11ac, of course. So the SOHO market, this is the consumer part of wireless LAN. In the first quarter, 1% of the units were 802.11 AC. And the enterprise market has not yet started shipping 802.11 AC. And I'd like to ask the panelists, how soon will customers demand 802.11 AC for enterprise class devices? And I'd like to sort of ask randomly Matthew Gast of Aerohive to address that question first, please.
Well, it happened to me yesterday. And it's been happening for a month now, so clearly this is something that is of great interest to the market. As always, it's a lot easier to do something in the SOHO space. You only have to get it working for a relatively small area. All of the enterprise class features that make Wi-Fi work like you expect it to based on your home experience in a large area, so that you can wander around and keep your phone call going, you can watch video, the fact that the network automatically configures itself. Those are things that unfortunately take us time to build as enterprise vendors. And one of the big enablers for Wi-Fi in the enterprise is that many customers want to have an assurance of interoperability. As an industry, I think we learned our lesson with early 11N equipment being not quite as interoperable as it could be. And a lot of buyers have decided to wait for the Wi-Fi Alliance certification program for 11AC to launch, and that's expected to launch this summer.
Okay, Walt, would you like to address this from your viewpoint?
Yeah, so from Cisco's perspective, we're launching our 11AC product actually next month in June. It's orderable today. We see actually a quicker adoption for 11AC compared to 11N, and it's largely driven by clients. It all comes down to mobile devices such as smartphones and tablets. If you look at how 11N got adopted, there was quite a latency with adoption. The first enterprise class 11N product came out to the market in 2007, but if you compare that to iPhone, for example, the first 11N iPhone was the iPhone 4 that came out in 2010. That was a 3-year delta between infrastructure support and actual clients using 11N. For AC, consumer-grade infrastructure products came out around middle of last year from the likes of Linksys and D-Link. And from the client side, the laptops came out at Christmas season last year, but the smartphones you've already seen today with Samsung Galaxy S4, with ZTE and HTC One phones as well. And very likely the next iPhone is going to be 11AC as well. So when you compare the lag between enterprise class APs and clients, you see that lag almost non-existent because they're coming out around the same quarter. When you compare that to 11N, that was like a 3-year difference. So I'm gonna say that 11AC adoption is clearly going to be much faster than 11N, and how those clients become pervasive on the network is going to drive the N or the AC infrastructure products as well. And I see AC being again white hot adoption this year.
Okay, this year. Stephen, would you like to address this?
Sure. We're seeing the same thing in terms of just the interest on the part of customers. We're coming out with an AC product later this year as well. But what we think is kind of interesting is to look more carefully at why people are interested in this, and it has a lot more to do with marketing than anything else we're seeing. Most of our work is in environments where you're looking at high-density deployments. And lots of users in hospitality and education and healthcare and the mobile operator environment where you're trying to serve the mobile internet in a place like this. And the major advantage of 11AC in part is what's accelerating the ability of the industry to move to it, which is there aren't really that many changes. It's just adding an additional bandwidth option in terms of the size of the spectrum band that you're using in 5 gigahertz, and a modulation class that's more complicated that you probably won't see in the real world very often. And the trouble is that wider spectrum reduces your spectral efficiency actually in high density situations. So in the residential environment where you only have one AP that won't see any of its neighbors, it's a real benefit, potentially. You might overwhelm your backhaul, but never mind that. In most places in enterprise where APs see each other, you have, in a sense, a GSM frequency planning problem, and AC doesn't really help that. So we'll see a lot of adoption of the first wave of AC for marketing reasons, because you get to put a big number on the box, and everybody likes to do that, whether you're the consumer or whether you're the infrastructure provider. But what's really going to bring a benefit in the most demanding applications for 802.11n is Wave 2 of AC, which I know is on your question list for later, when multi-user MIMO shows up, which we'll talk about soon, I'm sure.
Angus, would you like to address this from Spirent's perspective?
Sure, and I think as most of the press here understand, enterprises are generally on a 3-year depreciation cycle. So I think the buying of next generation AC solutions will depend on that cycle to some degree. And I agree with Walt said with regard to the certification of AC, which comes really starts happening this year. I think the other part that's interesting is on the consumer side, and especially the effect of BYOD for the enterprise market. So on the consumer side, we're seeing, as everybody is aware, significant growth in the smartphone side, close to 700 million smartphones out there, smart TVs, also tablets. So these are very high growth areas, and these new tablets and smart TVs and smartphones will be putting in the AC chipset. You were seeing announcements from Broadcom and from Apple and others along these lines. So we'll start to see those deployments this year, which I think will in turn influence what happens in the enterprise. This is certainly not scientific, but Netgear is shipping a AC router today, and one of the commenters on Amazon said he replaced his home 802.11 infrastructure with 802.11 AC. And even though his service provider, he had 30 megabits down and 6 meg up, with his end infrastructure, he was only getting 12 and 3, but now he's getting 32 and 6.4. So I think there's some other benefits with regard to that as well.
Dirk, I'd like you to address this, but one of the things I was trying to get to was how soon will customers actually demand 802.11 AC? So please.
It sounds like the panel here is in violent agreement. And to answer your specific question, I would categorize what we've seen so far as interest, but not demand. And I think what my 20 years have shown me, the first decade back at Xirrus, is that clients lead the infrastructure. So you have to have the clients out there in mass before folks actually wake up and say, hey, maybe it's time to migrate my infrastructure. So the good news this time around, as was pointed out, is I think AC clients will show up faster than say 11N clients did, but I still don't believe we're going to see significant demand from enterprises to move their infrastructure until at earliest late this year, probably next year. I mean, I think we're all going to have our products in the market earlier than that, but I think we're not going to see a big shift on the enterprise side in demanding the move to that infrastructure until it'll probably come on in a big wave next year.
Okay. All right. So it's client availability is one of the drivers towards the adoption of AC. I think is where we're coalescing here. Okay. So what's happening with 802.11 AC is there's kind of like two flavors of it. There's the one that's coming now, Wave 1, and then there's the one that comes next, Wave 2. And I got to wondering, is it worth, for enterprise customers, is it worth waiting for Wave 2? It's kind of a sensitive topic, I suppose, because if your customers wait, then they're not buying the one that's available now. So I'd like to hear panelist viewpoint on, is it worth waiting for Wave 2? Is there enough in Wave 1 that's, that's worth buying today, or let's say this calendar year when it launches? And Stephen, because you front ran that question before I guess you can address it first.
Sure. Well, it depends a little bit on what you're trying to achieve. As I said, some of our service provider customers are looking at AC from marketing purposes. So if they can say that they've got an AC-ready network, that sounds better. If what you're trying to do is just deliver raw capacity to your end users in a high-density environment, then N is perfectly fine because of that spectrum reuse problem that I mentioned earlier. So I think you'll see kind of a mixed bag in terms of people deploying it for marketing reasons in the short term, and people waiting for the AC upgrade, but continuing to roll out a lot of great 11N products in the medium term.
Okay. Would any of the other panelists like to address Wave 2?
Sure, I'll take that. The way that I look at it is that, or well, I should say, we have a saying at Aerohive that we started the company with the idea that everybody would have two devices, a laptop and a phone. And unfortunately, we were wrong. New stuff keeps getting invented. I'm shocked by the number of people who seem to carry multiple phones or also add in a tablet or have giant phones that look like tablets that went through the dryer on high and shrunk as a result. And 802.11ac is good at increasing capacity. There are features in the standard. It's not just about the maximum data rate that you can get, although those are certainly very high. It's always nice when you can pull a Dogbert and say the speed is big and round. But there's also an important set of coexistence features, so that as you set up a wide channel, 802.11ac has the capability to essentially expand to fill. And I mean, expand to fill is kind of a sensitive topic in networking for our customers, but I can't think of many places in the history of this industry where you would have gone wrong by betting that users will send more data. The one real counterexample is ATM, and I guess at an Ethernet event, it's perfectly fine to make fun of ATM. So you have these wide channels, and one of the cool things about 802.11ac is that even in the first wave, it lets you have the transmission take up as much spectrum as is available. If you have the full channel, you use the full channel. If you only have half the channel, you use half the channel. And that, by the way, is still the same size as 802.11n today. So it gives you this ability to burst, and that can make the network more efficient. If I wanted to get really technical, I'd point out that the latency in the network is proportional to the load that's placed on it, although anybody who drove here this morning knows that by the queue on the on-ramp. So just being able to cut down on the size of the queue by having some packets go out very fast when the whole channel's available, you get benefits from deploying 802.11ac from the first 802.11ac client that comes onto your network. And that advantage is already compelling if you're running at capacity. Now, as Stephen said, there is an engineer in me. We answer every question with, it depends. And it does depend on the environment as to whether that's useful for you or not. If you look at an environment which is nice and open like this, 802.11ac has much bigger advantages than if you have an environment where everybody has an office and you have to be shooting signals through walls. So there is a decision to make there, but the advantages of 802.11ac's coexistence with older 11n devices and being able to slip in big frames and go fast is already compelling in the first wave. And I would be remiss as somebody who has a lot staked on the future of Wi-Fi not to say it'll only get better in wave 2, but I wouldn't wait for it.
Dirk, would you like to address the second wave of 802.11ac?
Perhaps a more a practical approach to this has to deal with the refresh cycles we see in the industry now. The technology in Wi-Fi has been changing rapidly enough. You're seeing refresh cycles below 5 years, down to 3 years, unlike Ethernet, which is stretching out. And in this case, I think the answer is if you've got a relatively old Wi-Fi solution, if you've got a 5-year-old solution, you're looking at something that's probably early 11N, or God forbid it's still AG, Don't wait for wave 2. It's time to move. On the other hand, if you've got a solution that's a year old, you just installed it a year ago, I don't think I can give you a compelling argument that says refresh now to wave 1 and then again at wave 2. So I really think it depends on where you're being caught in your refresh cycle. And if you're thinking in a mindset of about every 3 years, I've got to be updating my Wi-Fi infrastructure, 5 years at the longest, let that just flow out as it naturally would, and it'll take care of itself.
Yeah, wave 2 is not going to happen until 2014 for consumer grade devices and 2015 for enterprise class probably. If the buying cycle is within the next 6 months, to a year, definitely, I think wave 1 11AC is compelling, especially for leading edge adopters like higher ed, large enterprises. The main value for AC, again, is because of the high throughput, the clients come on and off the network much faster. And for mobile devices like smartphones and tablets where battery saving is important, having those clients come on and off faster means better battery consumption, so longer battery life. And that will, again, drive adoption and how IT will push that adoption across enterprise.
I think what's interesting too, the general consensus was that Wave 2 perhaps wouldn't be available till later 2014 or perhaps 2015. Recently, Quantenna announced one of the first Wave 2 chipsets will be available in Q3, and they'll support multi-user MIMO. So that could potentially mean that by the end of this year, we could start seeing some of the first Wave 2 devices enter the market. From the Spirent perspective, we work a lot with carriers and their handset testing. And from a subscriber experience point of view or a quality of experience point of view, the carriers are focused on offloading a lot of their cellular data or their LTE data onto Wi-Fi. However, what a lot of the carriers see today is that many of their customers actually turn off Wi-Fi because it's slower than LTE. So when we talk to some of our carriers, they want to have perhaps 50% of their data actually offloaded to Wi-Fi. So there's a pretty significant challenge that the carriers have today. And I think with Wave 2, with multi-user MIMO, that gets very interesting for the carriers in terms of deploying Wi-Fi offload capabilities. Okay.
That actually reminds me to address the topic of service provider Wi-Fi. So it's our market forecast that there will be an installed base of around 10 million service provider Wi-Fi hotspots in 5 years. And if we run through data calculations, it appears that infrastructure could support as much as half of mobile device traffic in 5 years. So I'd like to ask the panelists just to kind of address whether 802.11ac will be part of that 10 million installed base, and if so, why? Why would a service provider care about that? Walt, do you want to address that?
Yeah, I think it depends on who the carrier is. So I think because the client adoption is pretty aggressive for 11AC, as I mentioned before, a lot of the higher end smartphones are 11AC enabled now. Samsung Galaxy S4 is one example. If they want to maximize that type of usage, I think the tier 1 carriers definitely could look at 11AC as a way to leverage that growth. High client density deployments in stadiums, auditoriums, I think also give way to 11AC, where you have better efficiency, great wider bandwidth to support more clients. I think that's going to be another driver as well. But there's going to be other carriers and where they're still price driven or cost driven, and still represents a good value for them to offload mobile traffic.
Any other panelists want to address AC in the service provider arena?
Well, if I can just pitch in, a related development in the Wi-Fi standards world is Hotspot 2.0, which hasn't kind of come up at the conference yet. But you could think about that in a sense as a virtualization of Wi-Fi capacity. And if you look at the service provider space, the thing that's often not really quite well understood is that 80% of their mobile internet problem isn't really mobile at all. It's in places just like this. It's indoors. And if you think about what they know how to do for a living, it's macro cells in the outdoor environment. And that's the hammer that they have in their hand, and they keep trying to tackle this mobile internet problem like it's a nail that they can hit with that hammer. And it's just not true. So if you look over the course of the next 2-3 years, and we have a couple of customers that are already doing 50% offload from their mobile networks onto Wi-Fi, and 80 to 90% of what they've deployed has been indoors. And as soon as you look at indoor environments where you have enough people to have the problem of the mobile internet demand density that we're seeing, it's enterprise. So in effect, there's a convergence of the enterprise and carrier worlds that will be enabled and accelerated by Hotspot 2.0, which enables, for instance, a financial services firm to sell a portion of its wireless LAN capacity to a mobile operator to help them with offload. This is already happening. The deals are relatively few in number, but that's happening. So all of the reasons why we talked about the enterprise looking to AC for capacity improvements where that actually works, and generally to improve their network from something that was a couple of years old now. You'll see that happening with more and more push to try to monetize that network to help the MNOs solve their problem. It's kind of a whole other discussion, but we think that's a key accelerator when you look at the deployment of Wi-Fi in the next couple of years.
I see. Would you like to address that?
Yeah, and to add on to that, we're seeing the emergence of some enterprises not selling the capability to carriers, but if you think about the comparison of the analytics that an Amazon has, they track every click you've ever made. So when I bought a big screen TV, 6 years ago, I spent a lot of time on it, and they still send me email about all the TVs they've just put on special because they knew I was very interested in it at one point. And you compare what the information that, say, Best Buy has, because I also walked into a store there, they have no idea that I bought a TV 6 years ago. And retailers who have physical locations are trying to close this gap. And one of the ways that they're doing it is to put in Wi-Fi in the stores. However, somebody has to pay for that. And you think of the typical IT budget at a retailer, and the IT department can't pay for it. It's the marketing department that can come up with the money, but they have to be able to justify that. And being able to use some of these capabilities to identify devices and then what they're doing turns out to be very important in justifying that. And it's almost like the retailer is becoming a carrier so that they can provide that access but also learn from it. Because when you get right down to it, you either are buying the product or you are the product. And this would be the latter case.
I think that the bottom line here is going to come down to business justification and cost. So the question was, will hotspots be 11AC? I think they will be 11AC when that technology and the premium for that technology is virtually zero above 11N. So I'm guessing that's probably in this upgrade cycle a relatively short period of time. Within 6 months to a year, we're going to see AC technology at the same price points or actually lower price points than you see 11N today. And then there's no reason for hotspots not to be 11AC.
Dirk, I'd like to just make sure I understand. You're saying AC pricing in 6 months is going to be like around where 11N is today?
Within a year, probably.
Within a year?
I mean,
okay.
I think it's going to collapse pretty quickly.
That would be faster than the prior cycles. Wow. Okay.
Bottom line about AC is everything's going to be faster, not just the technology, but the adoption and the price erosion.
That is interesting.
And I agree with Chris's charts. Within 5 years, we'll see the majority of chipsets shipping being AC, and probably actually tri-chipsets being 11N, AC, and AD within the next 5 years. And it's also interesting what some of the TV operators are, how their networks are changing in this face of a digital IP network. So for example, Charter's seeing a lot more subscribers on their internet side and not as many subscribers on their traditional RF video offering. So they see an opportunity to go to an all digital network, which means they don't have to spend as much money on that set-top box and that RF connection, which in turn relates to the adoption of those tablets and those smart TVs, all using AC. So the overall environment is shifting towards this capability, facilitating broader adoption of AC faster.
At this point, if there are any questions from the audience, now is a really good time. We're taking the microphone to people raising their hands.
What I'd like to understand is why 802.11n didn't fulfill its potential and promise, particularly with respect to home networks, where the majority still use wired multimedia over coax, MoCA connections, and why will 802.11n be successful in fulfilling its vision, objectives, goals, etc., where 802.11n failed?
Would any of the
Legitimate question?
Would any of the panelists like to address this? The question is, 802.11n, why did that not fulfill its potential in the home? In the home networking. Okay.
So if I understand the question, it's equivalent to when did I stop beating my wife? The assumption in here is that it has failed, and I will argue the point that it has not, that with an 11N system properly deployed in the home, properly deployed being the key answer, you can in fact achieve video distribution and do that. The challenge has been both in the home, and we're seeing it in spades in the enterprise, being able to deploy a network properly, easily, is critical. So the shift in emphasis, certainly on the enterprise side, has been toward ease of deployment, ease of management, and making it easier to deploy wide, broad wireless networks. Not a simple task, hasn't been, getting easier, and you'll see a lot of focus on the management solutions for both designing and deploying the network, and you'll see a lot of this being moved into the cloud to make that simpler too. So it's an issue in enterprise, but it's also going to remain an issue in the home, but I think you're going to see a lot of creative solutions about how to design, deploy, and manage these networks, and that's going to be critical. The technology, the bare technology itself at the physical layer, perfectly capable of doing that. You got to help the users figure out how to do it right.
Stephen, would you like to?
Yeah, so Ruckus actually started its business in the IPTV distribution market in the residential environment. And the critical thing to understand about that residential environment is just pure cost sensitivity. Whether you're the service provider installing it or whether you're the customer themselves, we find it to be true that a very, very small percentage of residential customers themselves will pay extra for a Wi-Fi access point to put it in their house because they have a big house and they have trouble getting to the corner. It's a tiny percentage of the market. The service providers that put Wi-Fi in their set-top boxes and in their modems, their cable or DSL modems, demand that that fit into an envelope of about $5 or $6. So you can put a Wi-Fi chip in there, but what you cannot do is surround that Wi-Fi chip with the proper number of radio chains and the adaptive antenna or smart antenna kind of technology you need to deliver a robust video link in a home environment where you have no control over where the user's deploying the set-top box or the modem. They can stick it behind the sofa bed in their home office in the corner of the home, and then you're SOL if you just have conventional reference design Wi-Fi. So it's not 11N's fault. We've delivered 11N we've shipped about 3 million units into that opportunity. It's just that that's a little bit more expensive than using home plug or one of the power line technologies. And the fixed line service providers tend to go with whatever's cheapest. We also ran into, in a couple of places, unions. Deploying Wi-Fi to do that solution is super cheap and easy. You can do a number of installations per day. If you constrain the installation to using the house's wiring, then the guys in the unions who do the installs can only do 2 a day. So there's a job preservation aspect of it as well, which is sort of a secondary effect. But it's not 11N's fault at all.
So AC really won't be big to resolve that problem. Presumably, it'll
Yeah, so the one thing that's true about AC is it finally delivers a standardized version to do classically defined phase and gain manipulation beamforming, which you can do in the chipset, and Quantenna is a great example of this. Whether or not those chipsets will reach the cost point that the wireline operators are looking for to fit it into set-top boxes and modems remains to be seen. That'll be a while from now, probably. But you may see more Wi-Fi doing those links in the future because of, and in fact, it's Wave 2 that delivers the actual channel feedback that you need to make that work. It's not in Wave 1. So never mind beamforming in the classic sense until you get to Wave 2.
I think the transition to all IP networks will accelerate this too. I have service from Time Warner, and they gave me 802.11 and Motorola router as part of that service, and I have smart TV and tablets that use that. Another challenge that we're going to have to overcome is the availability of frequency and the interference and congestion, and this goes to Dirk's point about the ease of deployment and management from a consumer standpoint. Because I remember when I was living in San Francisco, I think I could see 19 access points from my condo. So the availability of new frequency is going to make that a lot more seamless for the home user.
Okay, next question, please. Second row middle.
I want to go back to the economics of 11AC, especially in residential and SOHO environments. Right now, the only available products are selling at a huge premium to the 11N products that are available. Is there anything inherent in AC that's causing that price differential? Or is this just that the suppliers are looking to, harvest the early adopters who are willing to pay more for this capability?
I think it's your traditional technology adoption cycle. You're going to pay more at the front end of the cycle. And as volumes go up, and I think in this case, with the rapid adoption both in the consumer devices as well as you've heard everyone here will be deploying these as well on the enterprise side, that rapid adoption is going to increase the volume quickly, so you're going to see a faster curve in terms of price decline this time around. It all has to do with adoption rate.
So in terms of the semiconductor content or the structure of antennas or any other part of that product, there's no reason why the 11ACs can't be as inexpensive as 11Ns?
In fact, I think 11AC ultimately ends up being cheaper because it's going to end up on smaller geometries that lead to power savings in the consumer devices and also smaller die size and cheaper cost.
And remember, it's volume that drives you down that cost curve. And the volume in the Wi-Fi industry just generally is bigger this year than it was the year before and the year before that by a lot. So it's just going to move faster.
Great, thank you.
Okay, I'm told we're approaching the end here, and we are finished with the wireless LAN presentation. I think most of us will be around after this presentation and for lunch. And if you'd like to follow up with us, I think everybody would be happy to. So with that, I'd like to thank the panelists for joining us to talk about 802.11ac and wireless LAN. Thank you very much.